Lesson 1-8, Combinations of Functions. There are 5 basic ways to combine functions. First several are pretty straightforward. To add 2 functions, you add 2 functions. To subtract 2 functions, you subtract them. Same with multiplying and dividing. Of course, when you divide, the bottom can't be 0. So let's try some examples. If f of x is x plus 2 and g of x is x minus 2, find f plus g of x. Well, that would be f of x plus g of x, or x plus 2 plus x minus 2. So x plus x, and then 2 plus a negative 2 is 0. F minus g of x. Well, now we subtract. So it'll be the f of x minus the g of x. So it'd be the x's would cancel out, so there's no x's, and then 2 minus a negative 2, that'd be plus 2, would make 4. Multiplying, we're just going to multiply them together. So we'll have the x plus 2 times the x minus 2. X times x, that's minus 2x, that's plus 2x, which go away, minus 4. And dividing would just be taking the top one, dividing it by the other one. So we'll have x plus 2 divided by x minus 2. Can't simplify that any further. The 5th way is a composition. It uses this little O symbol. It's f composed with g, which means the g of x is put inside the f of x. It's substituting function g into f, so that x in f is being replaced by the entire function g. So f composed with g is f of g of x. The second one goes into the first one, so we're taking all of that and plugging it into the x there. So that was x squared, but the x is replaced with the other function, x minus 1, which you could simplify. That's the same thing as x minus 1 times x minus 1, which is x squared minus 2x plus 1. How about the other way around? G composed with f. This time, I'm taking all of function f and I'm plugging it into the x in g. The second one goes into the first one, so if f is being put into g. G was x minus 1, it was x minus 1, but x is now x squared. So usually write x squared minus 1. It's just substitution. Take the second function, plug it into the first function. The domain of f composed with g is all the x's in the domain of g, such that g of x is in the domain of f of x. So you have to look. You take all the x's, you look and see which x's are allowed in g, and then which x's are allowed in f. But remember, function g is what goes into f. So if f of x is the square root of x and g is 1 over x, find the domain of f composed with g. All right, the domain of g is x can't be 0 because you can't divide by 0. The domain of f is x has to be greater than or equal to 0. Okay. Now, The g is going into the f. So if we were to compose this, the g is going to go into the f, so it would be the square root of 1 over x. Well, we already know it can't be 0, because you can't divide by 0. And the things in the square root have to be positive, so that we know the x has to be positive, but it can't be 0. So our domain of the composition is x is greater than 0, not equal to. The equal to 0 got lost because we can't divide by 0. If you want to go the other direction, instead of composing functions, you want to decompose them or take them apart, you need to find two functions, f and g, so that the composition of them is h. So really what you're going to do is you're going to pick a portion of the function to be g of x, and then you can replace that with x to get the f of x. So you're going to take something and say, this is g of x. Whatever that was gets replaced with x. For example here, can you see some function or some part? All right, how about if we say the stuff in the square root is our g of x? All right, what's left then? What's left is the 2 on the outside and the absolute value bars. The thing we took out, this x plus 3, just replace it with an x. And that is one possibility. There are many possibilities. You could have called g of x the absolute value of x plus 3. Then f of x would have been just 2x. Let's try another. Well, what looks to be useful? Well, here's an inside piece right there. So let's call that our g of x. And you could have picked something different. What's left is the cube root, and the box, the stuff we took out and called g, just call it x.